The op-amp has two inputs and an output, and it follows two golden rules. No current is allowed inside the two inputs, and rule number 2 is that V out is going to be V plus minus V minus times the gain of the op-amp. Now, the gain can be either infinitely large or it can be not so large. When the gain is infinitely large, only negative feedback is allowed. What is negative feedback? When the output has a feedback loop to the inverting input of the op-amp. I put a square here in symbolizing an impedance, so it can be either a resistor, a capacitor, or whatever. Same thing with here. And this point now is going to have a voltage, the same voltage as this point over here. V minus will be equal to V plus. In that case, this point will be called a virtual ground. The virtual ground has a voltage of 0 here, even though it is not actually shorted to the ground. So no current leaks to the ground over here, but this point is forced to have a voltage of 0 like here, because this holds true. Similarly, here, when this point is not grounded but is connected, let's say, to a voltage source of V1, then this point here will be called a virtual short instead of a virtual ground. And the voltage here, V minus, will be equal to V plus, which will be equal to V1. So it's like this is shorted to this, but no current leaks anywhere over here. It doesn't leak over here. It only is forced to have this voltage. Now on to case number 2, when the gain is not very large, we symbolize it like this, so we show it like this. The gain is plus A over 2 minus the minus A over 2 over here, or you can see it like a gain over here and this grounded. So again, the gain would be A minus 0, or you can see it written like this, A or A0 inside the op-amp. And now this equation we had from before is going to hold true no matter what type of feedback we have. So we can have positive feedback. It's very rare, but we do have it. In any case, this will hold true always. So again, let's start from this point. This is not going to be a virtual ground like before, because this V minus is not going to have a value of 0 now, because this gain over here is not infinitely large. So since this is not infinitely large, if V plus is 0, we'll have that V out is going to be equal to minus V minus times A. So V minus is going to be equal to minus V out over A. Clearly, if the gain here is infinite, this V minus reduces to 0 like our previous case from before. So we are correct. Going to the other case over here, this point again is not going to be a virtual short like before, but instead, working similarly and replacing all values over here, if V plus is not 0, let's name this voltage V1, and then V minus is going to be minus V out over A plus V1. If this V out, if this gain is infinitely large, this whole thing V minus is going to be equal to V1 just like before. Again, for both of these cases, I used this equation. For that case, the gain is infinitely large, but we expect a finite output. So this is infinite, but the output is finite. That means that this whole thing must be very close to 0. And that's why V plus is equal to V minus over here. But in this case, when this gain is not infinite, well, things are a bit different. Congratulations, you've learned the 2 golden rules of the op-amps. Now you can go ahead and solve any type of exercise you want, now that you have the fundamentals in place. Also, check out the op-amp playlist over here. Study well and take care. Goodbye.